Moncrieff
with Energlaze
on Newstalk.
Now, if you're a nervous flyer, this item, the item we're going to do now might not be for you, because a lot of passengers don't like it when the aircraft is buffeted by turbulence, but it seems as turbulence is increasing. Scientists at the University of Reading have been studying this, and we're joined from there by co-author of the study, Professor Paul Williams. Good afternoon, Paul.
Good afternoon, Sean.
What causes turbulence in the first instance?
Well, it's kind of complicated. Lots of different things can generate turbulence. The wind blowing over a mountain can do it. Warm air rising and forming clouds and storms can obviously do it as well. You never want to fly through a storm. But the kind of turbulence we've been analysing is invisible. It's called clear air turbulence. And it's just generated by wind shear, which is changes in wind speed, rapid changes in wind speed in the atmospheric jet streams. And we've had this notion for many years now that climate change might be strengthening it. But that's all been based on kind of theoretical computer models. But what we finally have now is some evidence that, yes, turbulence has in fact started already to increase. And we've seen actually large increases over the past few decades.
Now, how do you chart the amount of turbulence there would be in a given week or month or year?
It's a tricky one, research-wise, especially this invisible clear air turbulence, because, of course, satellites can't see it. The pilot can't see it. The radar on board the plane can't see it. It's literally kind of invisible and comes out of the blue. But what we can do, there's a little workaround, if you like, because what satellites have been measuring since the 1970s is the three-dimensional shape and structure of the jet streams in the atmosphere. And it turns out that if we know that, we can actually calculate how much turbulence that jet stream would have been generating. And that's exactly what we've done in our new study that's just come out. We've analysed 4 decades worth of atmospheric observations of the jet stream, crunched the numbers to work out how much turbulence there would have been. And as you've alluded to, we know, for example, we've calculated that there's today 55% more severe turbulence over the North Atlantic, 41% more over the US, and similar figures elsewhere around the world. So these are the changes that have happened in the past 4 decades. So it looks like flights are a lot bumpier today than they were decades ago.
And that's a fairly dramatic increase to take place over 4 decades. And explain exactly, Paul, how climate change has affected this increase.
Yes, it's not an obvious link, is it? Because obviously our carbon emissions are warming the atmosphere, but what's that got to do with turbulence? Well, it turns out that if we go up to 40,000 feet, which is where a typical commercial passenger aircraft will be cruising, it turns out that it's not warming the same amount everywhere. There are atmospheric feedbacks taking place, feedback loops, where warming creates more warming, which creates even more warming, like a vicious cycle type of effect. And that is having the consequence that the temperature difference across the jet stream from north to south is today a lot stronger than it was 40 years ago. And we know that temperature differences generate wind shear in the jet stream, and wind shear generates turbulence. So that's the link there, from temperatures increasing the temperature differences, generating more wind shear, and that's what's generating more turbulence.
Does it affect the intensity of the turbulence?
It does. What we've done is there are ways of kind of quantifying or describing the strength of the turbulence. We've got these categories that go from light to moderate to severe to extreme. A bit like the Richter scale for measuring, how much energy is in an earthquake. We've got a similar scale. It doesn't have a name, but there is a similar scale for measuring the strength of turbulence. And we see that light and moderate and severe are all increasing. So this is an increase in the amount of turbulence in all of these categories. Light turbulence, nervous flyers don't like it. And by the way, something like 1 in 4 of us has a diagnosable fear of flying, according to the statistics I've seen. So nervous flyers really aren't going to be happy about this new study. But even the moderate and the severe turbulence is the one that has the potential to cause injury. Severe turbulence is stronger than gravity. So the up and down motions of the plane, in severe turbulence, the plane will be being pushed down by the turbulence, more strongly than gravity can keep you in your seat. So if you're not seatbelted, you'll start to lift up and potentially become, in the worst case, a projectile and sort of start, diving around inside the cabin and maybe flying up to the ceiling. So it really can injure people, this severe category of turbulence.
Okay, I warned you, listeners, about this. And I suppose even more worrying, clear air turbulence can't be spotted, or is there a method of spotting it?
Well, there's some experimental technology, and they've done test flights. It's called LiDAR, and it operates on the same principle as radar, but uses a different kind of wavelength of light. And it turns out it can see this invisible clear air turbulence, but we're not currently using it just because it's too expensive. But maybe that will change in future. And just to reassure listeners, because I know there'll be people on their way to the airport now, and I don't want to be scaring people. Turbulence is rare. When we say there's been a 55% increase, in the 1970s, there were only 17 or 18 hours of turbulence, severe turbulence, in the entire year over the North Atlantic. And that's increased to 27 hours today. So still only around one day in 365. So that just tells you how rare this kind of turbulence is.
Yeah. And is it relatively easy to avoid turbulence or fly out of turbulence? Or if you're going in a particular direction, you kind of have to just tough it out for a while?
Yeah, to some extent. I mean, obviously, if there's a massive storm in the way, you presumably try and go around it. But this clear air turbulence, often the first time the pilots will know it's there is when they're flying through it, because there's literally no warning. I mean, pilots do talk to each other over the radio and they'll share information, but it rapidly becomes out of date. There are forecasts as well, just like weather forecasts, but, specialized forecasts mapping how strong the turbulence will be rather than the temperatures and the rainfall. And they're about 80% accurate. And so pilots will certainly do their best to plot the smoothest route by consulting these turbulence forecast charts before they take off.
If it's increased though by 55% in the last 40 years, there's no reason to believe it's not going to continue to increase.
That's what our projections are telling us. And again, at the great risk of distressing any nervous flyers who are listening to the show, Sean, our calculations are saying that turbulence could triple on North Atlantic routes and basically around the world, North America and Europe as well, triple in the next few decades, just as the climate continues to warm. And those temperature differences in the upper atmosphere get stronger and stronger, driving stronger wind shear in the jet stream and generating, as I say, double or treble the amount of severe turbulence. So, bad news if you're not if you're a nervous flyer.
Time to consider a nice cruise. Professor
Yes.
Paul Williams is an atmospheric scientist at the University of Reading. Paul, thank you very much for speaking with us today.
Moncrieff, weekdays at 2 p.m.
with Energlaze
on Newstalk.